first thing that you're ever going to do is write a balanced chemical equation with the context given. All right, that should be your first step. So why is this? Because in stoichiometry, in a chemical equation, the coefficients are going to indicate the ratio of one substance to another in this reaction, okay, how they react with each other. So the formula that I'm going to introduce for this part, you've probably heard of it before, is the moles of your unknown substance that you're looking to find is going to be the ratio of unknown to known. So the coefficient of your unknown is from your balanced chemical equation, okay, divided by the coefficient of your known multiplied by the moles of your known, okay? So you may or may not have seen this being thrown around a bit, but let's see how we can use it, okay? So say we are given this following equation, okay? We are told, so this is our balanced chemical equation. They've already done this for us. So if you have 6 moles of H+, how many moles of Fe3+ would be produced? So what is our unknown? Our unknown is Fe3+, okay, because we don't know how many moles of it we have. Our known is H+, okay? So the moles of Fe3+, our unknown, is equal to the coefficient of our unknown, Fe3+, divided by coefficient of our known, which is H+, multiplied by the moles of H+, our known. Okay. So this is, in our equation, the coefficient of Fe3+ is 5, coefficient of H+ is 8, and the moles of H+ is 6. Okay, so this should give us 3.75 moles. Okay, I just ignored the sig figs. This is around about 4 moles, but let's just keep it at 3.75 because I'm just giving you context on how to use the formula, okay? Cool, so that's what this essentially means, this formula here. All right, so then how can we use what is the entire process of solving a question like this? Most of the time, you'll be given questions like this one, this example here. So calculate the mass of lead iodide that can be made from the reaction between lead nitrate and 30 grams of potassium iodide. Okay, so before we do anything, let's write down our balanced chemical equation. All right, so the reaction is between lead nitrate and potassium iodide. Okay, so Pb NO3 for this question, assuming that Pb is Pb2+. Yeah. And potassium iodide, so just Ki. Okay, this turns into, so we're swapping partners here, so PbI2. Now, iodine is in group 17, right? Remember, anything in group 17 is insoluble when it's with lead or silver. Okay, that's from last week's booklet. Yeah, so PbI2 must be a solid. That's why in the question they're asking for the mass of lead iodide produced. Okay, usually when they say mass, not always, but most of the time they mean that it's a solid. Okay, that's why you can measure it in mass. If it was a gas, they would say like the volume, all right? That's just how they're commonly associated. Okay, and the other one would just be KNO3. Is this balanced? No. Okay, we need to balance it. All right, 2Ki and 2KNO3. Yep. Now we have our balanced equation. Now, let's then identify what is our known and what is our unknown, okay? Because that's what we're going to use to do our calculations. So the unknown is obviously our lead iodide, okay? Because that's what we need to find, the mass of lead iodide. Our known is actually going to be our potassium iodide, because we are given its mass, but we don't know the mass of lead iodide. Okay, so before we can find the mass, okay, we're going from the mass of potassium iodide to the mass of lead iodide. So we need to find a connection between those two substances, okay? So the way that you can draw the connection is, say you are using, potassium iodide, you are using 1 mole of potassium iodide, okay? Then you are essentially going to be producing 0.5 moles of your lead iodide. Why is that? Because of the coefficients, okay? So for every say 2 moles of potassium iodide consumed, you're producing 1 mole of lead iodide. Okay, let's work in whole numbers. That's probably easier. Does that make sense? So that is where this formula comes from. So before we can use the formula, because the formula only works with moles and we are given a mass, let's convert this first into a mole. So we want to turn the mass of potassium iodide to the moles of potassium iodide. Okay, we're using mass over molar mass. So 30.0 divided by, what's K? 39.1 plus iodine is 126.9. Okay. And you should get about 0.1807 moles. Okay. Now, let's do our transition from one substance to the other. So we want to find the moles of lead iodide. Okay. This is going to be the ratio of unknown over known multiplied by the moles of your known, Ki. Okay. This should give you 0.09036. Again, I'm not worrying about sig figs at this point. And from this, finally, you can find the mass of your unknown, PbI2, moles times mole mass. What would be PbI2? You should get 461 as the molar mass. And your total mass should be 41.7 grams. Okay, this isn't 3 sig figs because this is your final answer.